Thank you. Hello and good evening. Thank you very much for having me. My name is Doran Angelovic. I'm CEO and co-founder of IONOTERRA, together with my partner, Professor Nathan Blaunstein, and our magnificent team of scientists and operational advisors. We predict earthquakes hours in advance. This is our statement. It says about everything we do. I will start by definition of what is an earthquake. An earthquake is not a spontaneous event. It is an event as a result of a continuous process, during the process or by the end of the process. IONOTERRA definition is a system enabling to predict earthquakes 8 hours in advance with a precision of over 90% in earthquakes events of above 4.5 Richter scale. We provide an output that we'd like to call 3 Ws. The first W is where is it going to happen? The second is when it is going to happen, and the third one is what magnitude it is going to have. How does it work? We consider the ionosphere a kind of a giant mirror reflecting for us everything that happens on the ground, sizing around 600 square kilometers above a seismic activity zone. There we see a picture which we call the soup, the boiling soup, because a lot of energies and bursts are reaching this ionosphere. We know to do things to this output. We know to clean the clutter and purify a very, very unique essence from this data, putting it inside our algorithm, resulting with the 3 Ws I mentioned before. This is how our system is deployed on the ground. We have sensors covering the 600, 700 square kilometers, which are constantly monitoring a certain region in the ionosphere. And we have another equipment that we developed, a ionozone, which is actually making these 2 procedures of 1, cleaning the clutter, and 2, getting the 3 Ws out of the purified data. How do we provide a proof that what we are saying is real? Well, we have conducted 2 POCs, proof of concept. One was held by the end of 2016, in which we had a posterioric POC. We stood at a certain point in time where an event happened and looked backwards 8 hours, 6 hours, 4 hours, 2 hours, and analyzed what happened in the ionosphere with ionograms, some 5,000 of these, looking for tendencies and patterns. After we discovered what we are looking for, we went back to the lab in order to improve our algorithm. And then we started in July 2019, a couple of months ago, our second POC, which was this time, and the very first, as we know, which is an a priori proof of concept. We are looking from a certain point in time to the future, trying to analyze and predict what's going to happen in the next 8 hours, 6 hours, 4 hours, 2 hours, and so on. We have analyzed above more than 14,000 ionograms so far, and it's still growing because we are still doing it. And I'm very proud to ever firstly expose the mid results, talking about the August achievement that we reached, which was far beyond our expectations. We succeeded in 82% of the cases. We missed 18% of the cases. Average prediction time for each and every event, the average was 3 hours and a half, and the average Richter scale was 2.67. Now, 2.67 is a very low Richter scale. Nobody dies because of a 267. But since we cannot wait years during a POC, we decided to go for whatever nature brings us. So our algorithm knows best to deal with catastrophic events. That means 4.5, 6, 7, 8, God forbid. By the way, today we opened the new session of our continuing POC, and we already have 2 what we call bullseye. We identified a perfect hit in 2 occasions. Some numbers about where we stand. Between the years 2000 and 2016, some 2,700 earthquakes occurred in the world, being above 5 Richter scale. Those events left us with more than 380,000 casualties, a number beyond our comprehension. Today, the world is using a variety of alert systems used by several countries, offering between 60 seconds and up to 7 minutes. What we are bringing to this equation is 8 hours alert, something that enables almost everybody to get ready and protect himself. This is the IONOTERRA system deployment on a countrywide expand. We chose China, of logic motives. We are dividing China into 3 zones, which is covering 28 seismically active regions that we know how to monitor. We divided them into 3 zones because they have the same behavior of ionosphere, which is something geographical. It's not the same behavior. Our economic potential is based on countries, on insurance, on industry, and on art. This is IONOTERRA, and my take-home message for you is now earthquakes can be predicted.
Thank you, Doran. A presentation with great magnitude. Judges, please.
Thank you very much. I'd love to know, how much would that actually cost? So for those 3 regions in China, for example, that you just told us, what would the cost be?
We are talking in China about 28 regions, 28 deployments, which are divided into 3 sections. Costs are being, at this moment, measured due to some suppliers, due to some geographical conditions. It would be a different cost for plate, flat geographical zone, and a different one for mountains. But I would be more than happy to give you a detailed response in writing in the area of few million dollars per unit.
Okay, do you know how much more that is than current systems that are in use? In terms of finances, is it dramatically different? I'm guessing it's a lot more expensive.
It is dramatically more expensive. The other system costs so far within the zone of hundreds of millions, around 1 billion as investments of countries.
Alistair, please.
As a layperson, this is extremely exciting, and whenever one reads about earthquake prediction, the kind of recurrent point is just how complicated it is. And so your approach of measuring ionospherics seems to represent, at least from a layperson's perspective, a major scientific breakthrough. Is that the case, or has this been reported on, researched elsewhere, and so is there competition based on that other research?
There is definitely a great breakthrough. I am, from obvious reasons, quite limited in describing, but this last POC, which is a month old, we have been talking in terms of Nobel Prize. And I'm not very, very bold in my statement. We had some other scientists, competitor scientists, let's say, that are willing now to collaborate with us, and when they saw the first feedback that we get, they went, wow.
Oh, okay.
One last question, very short one, please.
So, if you want to win a Nobel Prize, have you published it?
We are in the process of collecting data and analyzing it. Once we will finish by the end of this month, we will start publishing, we will start collecting the data, making it look like a research.
There's no patent.
Excuse me?
It has not been patented.
It was patented. We had a patent until 2018, and when I went to renew it, I understood that I have to give a wider range of information in order to cover the existing one plus protecting it. We decided strategically not to go for a patent in order to keep our information for us exclusively.
So basically this is unpublished and the breakthrough happened in 2019 and yet you patented it before that?
Yes.
I'm confused.
Last comment, please.
The first phase of the Professor Nathan Blaustein 30 years of research was patented in the US until last year, but it was a narrow range, less wide than we are now able to patent. And we decided at this stage not to patent a wider patent due to, let's say, discrepancy.
Thank you. Big applause for IONOTERRA.
Thank you very much.